Hi folks. This week we've got a particularly tricky your turn question, so I decided to put together a little video just to show you how to get started with it. It's the direction to a constellation question, where I ask you to describe where in the sky you expect to see a constellation at different times of the night and different times of the year. Now to start with, you need to understand that exactly which constellation it is isn't going to make that big a difference, so long as the constellation isn't near the celestial poles. So I started out by asking you to pick the constellation in your group that's closest to the celestial equator. Now remember that the celestial equator is at 0 degrees declination. So the closer your constellation is to 0 degrees declination, the closer to the equator it is. Now in this question, what I really want you to do is think about how the Earth moves, because we're going to really use that motion to understand how the view changes. So to do that, the real key is to draw a good picture, to have the right diagram. So let's do that. Let's take a look at what the question is asking. And it's saying that your constellation is in the sky at noon, and the sun is between you and the constellation. So let's break that up and see what that's telling us. Let's start with the at noon part, because that's really key. So we're going to draw a picture that's going to illustrate that at noon. Now remember, to do that, there's sort of three things we're going to need to have. We're going to need to have the Earth. Here's the Earth. We're going to need to have the sun. And we're going to need to have our observer. And our observer is at noon. Now remember, noon is a place. Now you say, wait a minute, what do I mean by that? Well, let's start by thinking about our view here. Since we're trying to observe the motion of the Earth, the spin and the orbit, I'm going to start by taking this view, looking down on the North Pole. So that means that in my view, there's the North Pole, right in the center. So we're looking down on the Earth's North Pole there. We know that when we look down on the North Pole, the Earth spins counterclockwise. So we're seeing the Earth's rotation like that. Now, I said it's noon. Noon is a place. In particular, it's the place that is facing towards the sun. It's always noon somewhere, and that somewhere always faces the sun. Just like it's always 5 o'clock somewhere, right? Same idea. So it's noon, and our observer is pointed towards the sun here. While we're at it, let's think about what other times are. If that's noon, then over here is probably midnight. And if that's midnight, then, well, let's see, the Earth turns this way, so that must be 6 a.m. And that must be 6 p.m. There. Okay, so we've got the Earth with our observer at noon, and we've got the sun. We need one more thing. We need the constellation. And the question said the constellation is located such that the sun is between the observer and the constellation. So the constellation must be way over here somewhere. I'm just going to draw an arrow and say it's out that way. Because really, we know constellations are made out of stars, like the sun. In fact, a lot of them are a lot bigger than the sun. So they're not in the solar system. They're not just sitting right here. Instead, they're some huge distance way out that way, and we're just looking that way. And so this is just the direction towards them. So with that in mind, there's our picture. This is where we start. Now, speaking of direction, that's the next thing we need to look at. Because what direction you're facing is a really interesting question here. And there's two things that complicate that. The first one is simply that there are 6 directions you need to worry about, not 4. Now, you know about the 4, the usual 4 directions that we talk about when we talk about what direction you're going, right? We say, well, there's north, and there's south, and there's east, and there's west. But now we're talking about things that move in space. And so we need 2 more directions. We need up and down. Up and down are also directions you can look when you're looking at the sky. And those are not the same thing as something like north or south. They're different. They're 90 degrees to that direction. So we've got to keep in mind we have 6 directions. And in particular, let's look at our observer here. Where they're standing, which direction is the sun from their point of view? Now, if you're just looking at this as some kind of flat piece of paper, you might say, oh, well, that side of the paper is probably west. But that's not going to work, because for a person standing on the globe right there, they have to look up to see the sun. And up is not the same as west. So they're looking in the up direction. And if that's not entirely clear, let's try it in 3 dimensions. So, again, here's the Earth. We're looking at it on the from the North Pole. And here is our observer. And if they're looking at the sun, which is over here, there we go. Which way are they looking to see the sun? Well, they've got to look straight up, don't they? Now, this picture is the same as this picture, right? It's the same picture. But maybe it's a little easier when you think of this as standing on a globe, because that's what was going on. Now, if that's up, then that way must be down. North for this person, well, look, there's the North Pole, so north must be straight into the screen here. East and west, well, look, west is that way out into the Pacific Ocean. East is this way. In fact, the Earth spins to the east. Oops, that way, that's east. Just like that. So this points out the other really important thing about this. As the Earth turns, as the observer is moved to a different location like this, or really as the observer's location moves, the directions change. So now that we're on this side, our observer says that way is up, not that way. Now it's that way for them. And that way is east. Look, see, that's going out into the Atlantic. That way is west, down into the Pacific. So that's the other really important idea here. Which direction is which depends on the observer's location. So as you are looking at this problem, as you are working on it, you always want to start by figuring out, where is my observer standing? Because that will tell you what the directions are. And you can't, just because the directions were a certain way at one point in the problem, after time has changed, those directions are going to move around with them. So you're going to be looking at the start of the question, which was like this. And then 6 hours later, like that. And then 6 months later, when the Earth has moved, in its orbit around the sun. And so you'll have to figure out where the Earth is gone at that point. But this picture is the same one. So this is showing us the same thing. It's just we flattened it down on a piece of paper so you could see it that way. All right, that should be enough to get you started. Give it a try and let me know if you have any questions.